Okay, welcome to the last talk before lunch. We are now in a talk on malware attribution by Michael Baumann, and I'm looking forward to the talk.
Thank you. So I'm going to talk about malware attribution, the theory, the code, and result of my research. A year ago, I was standing here and talk about my strange hobby, which was malware analysis. And I'm here now talking about most of the results of that hobby. I've been playing around for a while, about almost 10 years I calculated yesterday, with malware collection and analysis. And I have changed jobs since I was here last year. I'm actually now working for an anti-malware company, which is not in any way associated with my research here. It's a pure hobby. It's done in my spare time, using servers mounted on IKEA furniture under my staircase. So it's I'm here as an independent researcher. So the agenda for today is the theory behind the malware attribution. We can talk about how I'm doing it with code and some of the results I've gathered so far. So malware attribution is to put a face behind the author of the malicious code. Greg Hodlund presented at Black Hat 2010 about how he did it. And I was like, damn, that's cool. I want to do it too. The thing is, he was talking about that his code was going to be released on like 100 CDs, go to his booth. The code was nowhere to be found, so I started from scratch. But let's back up a little bit. What are we trying to do? We want to move from binary to more of the human side. We won't be able to get to the human, which means face and name and address, the physical address. But we want to go from just checksums as well. So it's totally, on the left side you have the totally useless stuff like MD5 checksums. They change every time you compile a code, you pack it. Yeah, totally useless data. What's starting to be interesting is the next step, the net recon, the command and control. That part is very nice to analyze, especially the command and control bits, because those seldom change. Because you have to think about it, if you change the command and control protocol, you lose your old botnet. You can no longer communicate with the old bots, so that's seldom change. Then you have the developer fingerprints, and that's everything from compilers, the development environment, to how the author is actually structuring his code. How big does he make his buffers? What libraries does he like to use? What versions? Then you got to the TTP, the tactics, techniques, and procedures. What is actually trying to do? Like, what's after? Is it stealing your credit card number? Is it stealing your WoW account? Is it stealing data? Is it just selling your machine as a spam bot? What is it trying to do? And how does it do it? Then you get more and more closer to the human. You're starting to find like your digital intelligence, like stalking the guy on Facebook and so on. And then you end up in physical surveillance with human intelligence, like stalking him in real life. Those last two I'm leaving to the professional, the police, and so on. That's not my hobby. So going back in more detail, so the net recon is your command and control. This is the encryption, your DNS, your protocol. Very unique. Oh, not very, very unique, but in context can be unique. You have developer fingerprints. It's the shell code, the exploit, the defensive, the anti-forensics techniques he's using for his code, if any, and the communications. All those combined can attribute a group or a single developer. Then you have your TTP, your intent, the installation, deployment. How does it get the code on your box? Is it a fake AV? Is it email attachment? How does it like to send you the data, the malicious code? The thing is, I have very limited time to do it. I had to start to concentrate on something. So I'm starting to concentrate on the dead code. I'm looking at the developer fingerprints. I'm right now just looking at the static binary analysis. The thing is that if I was to run this in a virtual machine, each sample takes about 5 minutes. I can run maybe 10 virtual machines, so I get 2 results a minute. It's still not a lot if you think about how fast I can do binary analysis. And I'm having a problem with disk space and hardware issues in general. So how do I do it? Well, it's a 3-step process. Now you're coming from binaries, it's 4 steps. First, you are gathering your malware. And sometimes you just look in your inbox, sometimes you actually go out and look for it. You go and extract your metadata from the binary, you're storing it, and you're analyzing it. So how do you go and get some malware? Well, I'm lazy. I want to have a pre-packaged malware, pre-found. So I go into virus share, the open malware, the malshare, cleanmx, malware domain list, etc. Using a cron job that just pull the latest stuff. Virus share, releasing a torrent with about 50 gigs of new malware every twice a week. So it's a lot. So first step, extracting metadata from binary. But what kind of metadata do you see in binary? Well, let's go through how you go around when you're compiling code. First, you have your source code. You have your tweaks and mod of the original source code. You have third-party libraries and third-party source code. All that, you're making a program. Throw it into the compiler, which has runtimes library, and the compiler is spitting out things like time. In the PE header, you have the compile time. You have some paths. Sometimes you can even get the path of the document and settings, which usually is a username. MAC address, the GUID version 1 had your MAC address as the last digits of the GUID. So if you if you're looking at old binaries, you can actually find the network code of the machine that was compiling the code. This is good if you're doing a forensic investigation. You actually find a suspect. You take his machine, doing some analysis, and say, "Oh, this MAC address, yeah, that one is bound to these malware samples." It's quite a strong case. Of course, MAC address can always be faked, but more difficult. So, what data am I collecting? Well, first of all, I'm doing hashes. I'm doing MD5, SHA-1, SHA-256, 512, etc., just to be able to identify the malware. So if someone says, "Hey, do you have this malware sample ID?" and I say, "Let me look." I'm also doing an SSD hash, which is a fuzzy hash. It doesn't need to be an exact match, just close enough. I also keeping track of like file type using FIS, using PID. So I get to know what the compiler, the package, the kind of executable. I'm looking at the PE headers, the imports, the exports, the linker, version information, everything. I'm grabbing the virus total results for good measure. And I'm assigning tags to the sample as well. So when you are identifying your compiler or package, that every time you compile a program, the compiler has some optimization, like how does it does the code? How does it transform C code to an executable? And the way Visual C++ does it is different from GCC, is different from GV, GCC. It's different between all the compilers. So you can look for those fingerprints and say, oh, well, this was a Boland C++, or this was a Visual C++, or this was a GCC compiler. Yeah, this is a PID Windows utility, but this doesn't really work for me because I'm into automation. I need to have it done, working when I'm not, or actually when I am working. So the putils library in Python has the same thing. It's using the same database. So I'm getting it programmatically. Then I'm keeping the PE header information. I'm not quite sure what I'm looking for right now, so I'm just storing the whole header information. It may be useful, it may be not. I'm just keeping it. And also doing a virus total result cache, but just because I maybe we want to look for a specific virus or family, or see if it was well detected or not when I found it. That data I'm not updating, is just when I found it, when I added it to the database, not what happened a week later. And I have this tag system where I can assign tags to the manual sample. So I can say that, well, this one is doing anti-forensics, this one's using the Tor network. I got this sample from virus share, and so on. So I keep in track of where I got it from, what have my conclusions so far, and I just add tags as I do in the analysis. Next step is to store the malware. I'm using MongoDB. I found it's suitable. I like to work with it, so it's like it's the hammer and everything. All my problems seems to look like snails. So I'm using MongoDB for everything now. And the author of Cuckoo Sandbox, he had released a project called VXCage, which is a Malware Repository. It's a REST API. You can just upload, download malware from it. The thing is, was using standard SQL databases and file system, and I wanted something more agnostic. I don't want to have it tied to a specific server. I want to be able to easily replicate the server. I want to be able to share. And I was reading through the MongoDB specifications, like, you want to share data? Yeah, just add another node and create a connection, and it magically happens. So like, cool. So I modified the VXCage server. My modification is collecting a lot of more metadata. The original just create the hashes. I'm collecting my PE headers and so on. I'm storing everything in MongoDB using GridFS. I'm not storing anything on file system. The REST API is quite simple. You connect to the web server and you ask for /malware/add to provide the post data to add a new sample. You do a GET request to get back the sample, and you can use any kind of hash. It doesn't matter if it's just more intelligent selection of the sample. The original needed to have a SHA-256 hash to get the sample. I'm doing a fuzzy, a more liberal search in the database, so I'm searching for all kind of hashes. You can get the metadata using the find API, and you can search then by MD5 sum, show sum, SSD, tag, date. I haven't exposed the whole MongoDB data yet, so, but in the end you should be able to query more or less directly to the MongoDB to get whatever data you want. So you say, I want this PE header, that's everything that matches this PE header and value, and like, okay, I'll give you. And I also can list all the tags, so I can search by tag. Now, this comes to the real thing. Did I find anything? That's a very good question. Did I find anything? Yes and no. We started looking at what are we looking for? We're looking for compiler, we're looking for linkers, libraries, strings, paths, P headers, compile times, number of times software being built. If you're compiling the bug version, your compilers are actually keeping track of how many times you have been compiling this piece of code. So you can see that, oh, now you're trying for the 28th time to get this code running. Also trying to catalog behaviors. Packers, if it's encryption, anti-debugging, anti-VM, anti-forensics. I'm just doing static analysis here. I'm looking for specific API calls or specific code strings, so code sections. So for the results here, been limiting what the results I have. It's a lot of data, and it takes a long time to do these graphs. Before I start, have you ever heard about SSD hashing? Any show of hands? So 4 or 5 people. It's SSD. It's a fuzzy hash. It's showing like close enough results. So I have an HTML page here that's actually containing some malware. It has 2 different MD5 sums, but the only thing that changed was the captcha code and the number of visitors of the page. So SSD says this is 100% the same thing. MD5 sum, it's not. I'm using this SSD data to compare each sample with each other, and you get a score of how much in common they're using. And I said, okay, give me all the samples at least 50% in common of my seed sample, and do it recursively. And I end up with a graph like this. So this is from a single sample I got. From that sample, I got extracted 3,006 other samples that are sharing code with each other. So you see here, you have in the bottom you have a main contributor to a lot of samples. That one is not sharing so much code with the one on the top. Can't show you on the top circle, but it's sharing some code on the left side with that bit of triangle. And between the top and the bottom, there's just one. You have a few samples that sharing code, but it's quite. There's a few common denominators. It's like. The top and the bottom doesn't share much code except this middle link. And that's good if you like say you get an unknown sample. You can quickly do an SSD hash and do a lookup of that hash and see if this one has code patterns that are known to belong to other malicious code that's already been categorized. not all samples are sharing code. Here you have a main sample that are sharing code with a lot of things, but I haven't found any samples that sharing code with those and a step further. But the thing is, I'm still doing the index building, so I'm having a big data problem. Just before I started this talk, I saw that I have 707,000 samples in my database, and I keep adding it as I'm standing here. And you have like the party handshake problem. So if I want to compare each sample with each other, I'm doing at 250 billion compares. And that was just growing. So I need to find a better way to pre-select what I'm comparing. I'm not trying to find all the same or similar code. I'm trying to find this that are at least 50% similar. So you heard about a lot of packers and compilers and so on. What is most common? So I asked my database, what are the most common packers or compilers? Bull and Delphi was the top scorer. For some reason, Delphi is very common in malware development. You just like it. Visual C++ version 6 and then 8, and then Visual Basic version 5. Also common. On 5th place, you got our first packer, UPX. So you hear about a lot of packing, but I don't see it right now. Then again, my sample sources are limited. I have not got up to date with the latest malware in my database. I'm still adding old stuff, but old stuff is like this year. Let's say if you want to look for any identified packers, how would you go about that? Well, a packer, if you look at the PE headers, a packer usually have an empty section, which is writable and executable, which is when you run the code, you unpack 2, but it's size 0 at the dead code. That's a giveaway. I won't say I find everything like that, but it's something to look for. Especially if you have such a PE header and there's no known packer, you can start looking and see if you can find anything to fingerprint. And then once you fingerprint it, maybe you can put a name on it. How common are the anti-debugging techniques? Not so much. This data is a bit misrepresenting because I'm actually blind for packed data. If you're using a packer, I don't see this is the debugger present until you unpack the code, which I'm not doing. I'm doing dead code analytics. So, but as you see, the UPX was the 5th most common packer or compiler. Any questions so far? I'm running out of slides here. I was hoping for more interaction, but yeah, good, great. So back to my coverage. Here's the code, how your binary is being developed. You have your source code, you have your machine, your compiler, you have your malware packing, and so on. I'm currently doing the packing and identification. I'm doing the time, the compiler, the runtime libraries, the API calls. I'm not yet doing all the string dumping. I need to go around and implement that one. But the time to add a sample is already increasing, so this morning I thought that, why am I trying to do everything at once? I should split up the problem and just go back to adding checksum and have other processes that go and do a batch job to add the other metadata. So I'm not need to wait maybe 10 seconds for every time I add a sample. So what I'm trying to do in the future, well, I'm going to expand what I'm doing. I'm going to start running all the samples in virtual machines and get the behavioral data of it. That way I can look at the command and control data, fingerprint that one. Because if, as I said in the beginning, the command and control protocol seldom change, or usually don't until it gets broken, because by changing it, you're losing your botnets. You're already losing your pre-compromised machines. So that was a very big as a good fingerprint, because even if you don't have the exact sample, the way they communicate is a giveaway. Also going to look at the memory, the OS changes, and the behavior. What are they trying to do once you get on the machine? How does it keep itself on the machine? How does it do in the persistence? Does it do DLL injections, other processes, or just staying in its own process? All that I'm going to put back into the database and start do data mining. And I'm doing like fishing expeditions. I'm not really know what I'm looking for, but as soon as it's like, I wonder how common is this setting or this piece of code or this flow of behavior calls, the API calls in this particular order. How common is that? I can look for it. So I need to do more automation. Currently, my code has a memory issue. It hangs. It doesn't free the buffers every so often. I have temporarily solved it by it killing itself, and then I have a script that automatically restarts it. There's a memory issue that I'm not freeing my objects after I'm done, and to hunt it down. I need to go back and do a more modular design. As I said, adding a sample takes way too much time. I mean, I want all the metadata, but I don't need it right away. It's more important than getting the data into the database, and then another process can do asynchronous updates to the database for the PE header information and so on. I don't need it straight away. I'm getting a big data issue. So I'm having 7 terabytes of disk space at home, and I have about half a terabyte free. I need to sort out my disk space issue, and I need to sort out how I actually going to do the compare, because getting the data is getting slower and slower and slower. The nice thing about having a big database is big, and even with indexes, they are slow, especially if you're doing advanced queries. I'm looking at this Hadoop thing and see if I can use that one to split out the load and making the problem a large, complicated problem to smaller, easier to solve problems. I also want to automate the pretty graphs. The graph you were seeing that took about 3 hours yesterday to render. The graphics library is good, but sometimes it's trying a little bit too hard to make pretty graphs, and it fails. I need to find another graphing library. I saw some Google talk about the new one that looks just like I want it. I haven't investigated any more time in how to use it. But basically, I want to have more graphs, I want to have it automated, and I want to have them pretty. So, thank you. The code will be available as soon as I have an internet connection. I can do a git push up to GitHub. So I haven't committed everything, it's just going to do a push. The code is under some open source license, which probably is GPL. I'm just using the same license as the original was using. And yeah.
Yeah. Thanks a lot. Yeah, I have some questions, but maybe there are questions from the audience before I as a...
Yes, a couple questions. You said you're doing lookups on VirusTotal.
Yeah.
Do you also submit any of the samples you're analyzing to VirusTotal, or is it
No,
just
no.
pure,
Right now,
you
I'm
do
just
lookups?
getting the cached reports.
Okay, the latest.
Yeah.
cache at the time.
And I have a problem with doing so much ending of samples that with the public API key, you can only do 4 requests a minute.
Yes. I know.
And I'm doing a lot of requests, so I have built a small proxy that is caching the results, and it's also doing some funky stuff with the keys, so I'm getting more.
Okay, that's good. You mentioned that you're going to analyze the binaries in a sandbox in the future.
Yeah.
What sandbox are you going to use for that?
It depends if my employer sponsors me or not. If it's continued to be a hobby project, I will use the Cocoa sandbox. And if I get permission from my employer, I will use our MAS or AX system it's called now, which is tons much cooler. So.
Okay, good. Thank you.
Thanks. More questions?
For your future work regarding behavioral analysis of the malware samples on your VMs, do you have any ideas of how you're going to start looking at that? I mean, it seems to be quite a hard problem doing binary analysis on already compiled malwares running on a VM. So I'm also looking at this kind of work by trying to study machine states and things, but it's really challenging. And I just wondered if you had any ideas on techniques that you would use.
Yeah, actually, I was thinking about compiling the API calls into some kind of pseudo code. I just shrink it down to just a few bytes and run SSDeep on it. Because SSDeep is very good at finding matching patterns. So I don't need to compile. I don't need to look at each and every call and compare them. I just say I have a summarized version here, and how much are they similar. So the thing is with compile code is that the assembly code can look a lot different to perform the same thing, but you need to make those API calls either by name or by ordinal, and just look for that. Does those API calls comes up in the right kind of pattern?
Further questions? Then I insert my own, maybe that spawns some further discussions. Did you analyze popular malware that is well known, like say Stuxnet or something?
No, I don't think so. I might have. I haven't looked at specific samples. I just grabbed like a random sample and was like, okay, how does this one look?
Okay.
So I haven't got back and like, how does the flame look like in regards to everything else and so on.
Okay. And a related question is, there are companies known to now have a product out there who previously have written malware, like Skype. They did some malware stuff before they did Skype, and all the techniques they are using, like Packer and everything, is also very malware-like. Have you tried analyzing existing non-malware software and comparing that stuff to malware you have found?
I actually have some ham in the code. I have like added Windows binaries and sysinternals and so on to add, but I haven't looked much into that. How much code that sysinternals have provided to malware authors in like this is how we do it, and they just copy it. I haven't looked into that yet. It's something I want to look at. I want to have a pretty graph where I can color code samples which has been high hit rate on virus total, low hit rate on virus total, and known good and unknowns. So I can see a colored graph, how they are compared to each other.
Especially correlations would be interesting because it could be that some malware author is also during his day work using some compiler suite or something that then turns up in malware samples. So that would be interesting. You should expect they would be knowledgeable enough, but you never know.
My experience is that they are like every other coders. They are lazy. I mean, it's very simple to clear out a lot of the PE header version information, but they don't do it.
Yeah.
So yeah, they're lazy. Then not enough people have been caught yet using this information.
Yeah. So if you catch somebody, maybe that gives you a further chance to explore that as a day job, because I find it very interesting.
Yeah, but you still have problems with the code patterns. It's not easy to change your coding style between each sample. You have your favorite buffer size. It's 256 or 255 or 124. It's like you want to, if you say I want to have a buffer for a string. Yeah, how many bytes do you reserve for that one? How's your structure, verbal structures look like?
Yeah. Questions from the audience? Any more? Over there? Or no? Are you keeping the samples, or?
Yeah, I'm keeping the samples.
So these terabytes you have are
samples.
So
sorry.
Mostly because the database itself is not that big.
No, the metadata is not so big, but all the binaries are also being kept in the gridfs inside MongoDB, and I also have the samples stored on this before I added them up.
Okay.
So when I download the sample from the internet, I still have to temporarily store them on disk before I'm adding them to the database.
So maybe one idea would be to only keep the extracted metadata, and only when you want to go back to the samples to extract further features, that you put that on a big tape like an LTO. You can store 3 terabytes on a current version, and it's not that expensive. Maybe just a suggestion.
Yeah.
Okay.
One more question. The CNC, like domains and IPs, that would be something that you typically discover during dynamic analysis. Have you done any string searching to see if you discover any IP address or domain hard-coded in the samples? Would that be something that you might maybe looking for?
Okay, I haven't done string extraction yet. I'm looking for, it's not difficult to do, it's just how am I going to store the data in the database in such a way I can easily look it up. Because I not only want to find a string, I would like to be able to find where that string is. So if I later extract the binary from the database, I would like to be able to go straight to that address and see where it is. But the routine I have for string extraction does single out IPs and domain names, HTTP protocol, and so on.
Okay.
Yeah, do we have further questions? Yeah, then thanks a lot. I think you're around if there are further questions, and I find it very interesting, and also that you publish the code. I think this is very valuable for others to look into. And
yeah, if Greg had published his code, I probably wouldn't be doing this project. I would just be using his code, but I find it useful for the code sharing is, if someone wants to continue or contribute patches, I would be grateful. And if you want to have a copy of my malware database, we have to find some ways to make sure that my home internet is not clogged by doing so. But I'm sure we could find somewhere. If you're working for an education institution, maybe you could mirror my data, and from there you can mirror out to other people. I don't claim any like copyright of the data. It's the ones who have the copyright is the malware authors, and I don't think they will stand up and say, "Hey, you copied my code."
Okay, good luck. Maybe you find a solution how you can turn this hobby into daytime.
Yeah, I hope to come back next year and present some more results. Maybe even a Facebook picture of some of the authors. Hopefully, you never know.
Great, thanks.
Thanks.